For topic 5, we're going to talk about area specifically of rectangles. Okay, so remember polygons. We talked about this in a previous video. Polygons are these flat enclosed figures made up of 3 or more sides. Well, a rectangle is a type of polygon. It's just a 4-sided figure. All right, we all in the real world know what a rectangle is. Okay. Now, the definition here, area is the measure of the space inside a two-dimensional shape. So a polygon would be a two-dimensional shape. It tells us how much surface the shape covers, okay? So if we had a rectangle, imagine we had a rectangle like this. And we broke it into these square pieces. Pretend these are perfectly square, okay? Well, we have 3 along this side. We have 2 along this side. How many of these squares do we have? Well, I could say, well, I have 2 rows. Each row has 3 in it. So that would be 3 times 2 or 2 times 3. So this would be 2 times 3 or 6 square units. I have literally 6 little square pieces. So that's what we want. We want these 6 little square pieces or whatever that final number ends up being. So the 6 little square pieces cover the surface of this rectangle. That's what area is. Okay, so key concepts. I drew this with little squares very much on purpose because we have to think of square units. When you're measuring area, you're measuring a surface, and we have to cover the surface with two-dimensional shapes. So we always use squares. Squares are nice. So we use square centimeters or square inches or square feet or square meters. That means you're literally looking at a little box that's a centimeter on each side, a square centimeter, or a little box, a little square that's an inch on each side, a square inch, or a little box that's a foot on each side, a square foot. That two-dimensional shape will cover a surface, so we have to have these square units. So when we talk about square units, it's the standard unit of measurement for area. So square inches, square feet, square miles, and it's literally a square that measures a mile on each side, a square that measures a foot on each side, a square that measures a yard on each side. That's how we measure area. And then a rectangle and a square has a very specific formula to calculate the area. We kind of could see it here. When we had this rectangle, I broke it into these 6 squares. I had 2 rows of 3 blocks each, or I could say I had 3 columns with 2 blocks each. Either way we slice it, we were able to take the rows and multiply it by the columns, or the columns and multiply it by the rows, okay? The same thing is true. The length makes up all of the rows, the width makes up all of the columns, or you could think of it, the width makes up all of the rows, and the length makes up all the columns, however your brain thinks of it. But length measures either columns or rows, and then width measures either columns or rows. So by taking the length and taking the width, we're taking the rows, multiplying it by the columns. Okay, that's really what's happening here. So area is quite literally whatever the length is times the width. That's what this is saying. Okay. So let's go ahead and look at some basic figures here. So example 6 says find the area of each figure. They're all rectangles, which is really nice. So for part A, it says find the area of the rectangle. Well, we have the length is 33 and the width is 10. So we could say the 10 makes up 10 columns and the length makes up 33 rows, however you want to think of it. So we would have 33 rows times 10 columns. And the cool thing here is we have a power of 10, what we just practiced in the previous video. So I can take 33 times 1, that's just 33. And then I can say, okay, well, I have this 1 0, so I just need to tack a 0 on the end here. And we can finally say that this is 330 square centimeters. So you can write little centimeter with the exponent of 2. That's kind of our shorthand way of saying square centimeters. So if we were to break this, imagine this was drawn to scale. We were to break this into little centimeter pieces. Each little square was a centimeter on every side. There would be 330 of them to cover that surface. Okay, let's look at part B. We have 8 centimeters by 5 centimeters. So that means there's 5 columns, 8 rows, if you want to think of it like that. So we want to take rows and columns and multiply them. So we would take 8 times 5, that's just 40, and it's going to be square centimeters. So again, imagine this was drawn to scale. Each row would have 5 centimeter squares in it, and we would add all those up and or multiply the rows and the columns, and we would get 40 of those centimeters, those square centimeters. Now, I kind of like this figure here for part C because they've got the grid behind you. So we have 5 centimeters by 5 centimeters. Notice if we were to go down this and look at the rows, you can see here, or the columns rather, We have our 5 columns. Each column has 5 blocks in it. That makes up our rows and our columns. So you can see all we do is take rows times columns. So 5 times 5, length times width, and that equals 25. Again, we're dealing with centimeters. That's just kind of happenstance that they're all centimeters. But there are, if you count, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 square centimeters. So there's 25 little squares, each measuring a centimeter. So it's 25 square centimeters. Okay, so hopefully if you didn't understand in part A and B, part C was like, oh, I see what's happening now. Okay, now last up it says find the area of the basketball court. It's a little hard to see, but this right here says 28 meters. And this is 6 meters. So we want to, let me give us a little bit more room. We want to take length and width. So length is 28. Multiply it by 6. If it's easier, you can do the vertical setup like we did in a previous video. So 28 times 6. We want to take the 6 and multiply it by 8. That's 48. So I keep an 8. I carry a 4. I then take 6 times 2, which is 12, and then I add the 4. So 12 plus 4 is 16. So we would get 168 meters squared. And that's it. So that's area. Just remember area, when you're talking about length and width, the length and the width make up the rows and the columns, and you just want to multiply the number of rows by the number of columns, and I'll tell you how many little squares of whatever size you have covering the surface of that figure, right?